Let's talk about a project so big, so ambitious, that it is literally going to change how we see the universe. This isn't just another telescope. This is a machine designed to answer some of the oldest, most fundamental questions we have.
Okay, so I want you to picture the most hostile and inhospitable place on our planet you can possibly imagine. A place so harsh, so utterly devoid of life that it feels like nature itself just gave up on it.
Now, what if I told you that this exact spot, this life-hating wasteland, is precisely where we're building our single greatest tool to find life on other planets? It's a wild paradox, right? So how is that even possible? Well, that's what we're going to break down.
Our story starts in a place that honestly feels more like Mars than Earth. We're heading to the Atacama Desert in Chile.
The extremes here are just staggering. I mean, this isn't just kind of dry. It is the driest non-polar place on the entire planet. There are weather stations here that have never, not once, recorded a single drop of rain. It's so alien that space agencies like NASA actually bring their Mars rovers here to test them out.
So you've got to be asking the obvious question. Why here? Why on Earth would you choose this brutal, barren place to build a multi-billion-dollar, hypersensitive instrument? The answer, it turns out, isn't on the ground at all. It's what's happening high above it.
Reason number one is the darkness. I mean, for most of us, the night sky is just a hazy orange glow, right? Washed out by city lights. But out in the Atacama, you're hundreds of miles from anything. The sky is so perfectly, pristinely dark, it allows a telescope to pick up the absolute faintest whispers of light from the very edge of the universe.
But pure darkness isn't enough. You also need clear skies. And this, right here, is the Atacama superpower. Because it's so unbelievably dry, there are almost never any clouds. To put that in perspective, a great observatory site in Europe might get, if it's lucky, about 200 clear nights a year. The Atacama? Over 320. That is just an insane amount of time to be pointed at the stars.
But here's the thing. Picking the perfect spot, that was the easy part. Actually building a colossal structure on a remote mountain peak 10,000 feet up in the air, well, that was a whole other kind of battle.
The engineering here was just biblical. First, they picked their mountain, Cerro Armazones, but its peak was too pointy to build on. The solution? They blew it up. I'm not kidding. They used explosives to lop off the top 100 meters. That crazy move led to a 5-year-long fight with sinkholes and unstable ground. Only then could they build a special earthquake-proof foundation, and finally start putting together a dome big enough to swallow the Statue of Liberty whole.
And just to give you a sense of what blowing the top off a mountain means, look at this number. 4.7 million cubic meters of rock were just gone. It's a number so big it's almost meaningless.
So let's try to picture it another way. That's enough rock and dirt to fill up nearly 2,000 Olympic-sized swimming pools. They literally moved a mountain to build this observatory.
And since this whole region is known for earthquakes, they couldn't just pour a concrete slab. They had to invent something incredible, a seismic isolation system. The easiest way to think of it is like a giant set of high-tech shock absorbers for the entire building. The ground can shake violently during a quake, while the billion-dollar telescope and all its fragile mirrors just float, perfectly still and safe. It's amazing.
So we've tamed the mountain. We've built the fortress. Now let's get to the main event, the jewel inside it all, the telescope itself. Its official name is the Extremely Large Telescope, or ELT, and trust me, that name is an understatement.
This table really says it all. The leap in power is just staggering. Don't even bother comparing it to the human eye. Its main mirror is 39 meters across. That's about half a football field. It will gather 100 times million times more light than you can. And look at this. Even compared to the legendary Hubble Space Telescope, the ELT will take pictures that are 15 times sharper. This isn't just an improvement, it's a revolution in what we can see. But wait, how can a telescope on the ground be sharper than one in space above all the atmospheric muck? The secret is this mind-bending technology called adaptive optics. You know how stars twinkle? That's beautiful for us, but for an astronomer, that twinkling is the atmosphere blurring the image. It's a total nightmare. Adaptive optics fixes that.
Okay, so check this out. The telescope shoots these giant, powerful lasers 90 kilometers straight up into the sky. These lasers hit a layer of sodium atoms, basically leftover space dust from meteors, and makes them glow. This creates artificial stars. Now, the telescope's computer knows exactly what those fake stars should look like, so it measures how our atmosphere is distorting that light. And then, Here's the magic. A flexible mirror inside the telescope changes its shape thousands of times every second to perfectly cancel out that distortion in real time. The result? You get images that are as sharp as if the telescope were actually in space. It is absolutely brilliant.
So all of this monumental effort, this insane technology, it's all for one reason: discovery. The ELT isn't just a bigger telescope, it's a time machine, and it's a world finder.
Remember, because light takes time to travel, looking deep into space is the same thing as looking back in time. Hubble let us see all the way back to 13.4 billion years ago, which is incredible. But the ELT's giant eye is going to push that boundary even further. We will actually be able to witness the very first galaxies in the universe switching on for the first time, just a few 100 million years after the Big Bang itself. But maybe the most thrilling mission of all is the hunt for life. The ELT will be the first telescope in history that can actually take direct photographs of Earth-like planets orbiting other stars. But it's more than just a picture. It will be able to analyze the light that passes through their atmospheres and hunt for the chemical fingerprints of life. Things like water, oxygen, carbon dioxide. It could even spot the signs of industrial pollution from an alien civilization.
Of course, a project this massive comes with an equally massive price tag. The total cost is pegged at around $1.6 billion. Just for some context, that's in the same ballpark as what it cost to build the Burj Khalifa, the tallest building on Earth.
And this isn't some far-off dream. Construction is well underway, and this revolutionary eye on the universe is scheduled to open for the very first time in 2029. We are right around the corner.
So when those giant dome doors finally slide open, the ELT will begin its search. It will look back to the dawn of time and out to our nearest stellar neighbors, all in the hope of answering what is perhaps the most profound, most important question we have ever asked ourselves: are we alone in the universe?